Welcome to another episode of Terry's Notes, and today we're going to be looking at the June 2015 paper, question 11. Okay, so the first part of the question, where we have a matrix A, which is 1, 1, 2, 3, and matrix B is 1, 2, 0, 1. And the first part of the question asks us to work out the product AB. Okay, so AB is equal to, we're going to put 1, 1, 2, 3, and then we're going to have 1, 2, 0, 1. Alright, now remember, when we multiply in matrices, we take our first row and multiply it by the first column, right? And that will give us 1 multiplied by 1 will give us 1, and 1 by 0 gives us 0. So therefore it will be 1 plus 0, which is 1. Then we need to take this row and multiply by this column, and that will give me 1, 2 will be 1 times 2 will be 2, and 1 times 1 is 1, so it'll be 2 plus 1, which is 3. And then we have to take 2, 3 and multiply by 1, 0. 2 by 1 will give me 2, and 3 by 0 will give me 0, so this will be 2. And then we have to take this row and multiply by, so this row multiplied by this column, so 2 multiplied by 2 will give me 4, and 3 by 1 will give me 3, so 4 plus 3 is 7. Right, so this is the product of AB. Right, so just recap what we're doing here. We have two matrices, A, B, C, D as one. Let's call this A, and we have another one which is B. Let's call this P, Q, R, and S. Now this is, in terms of row, this is row 1 and row 2, and in terms of column, this is column 1 and column 2. Right, now if we have to work out this product here, we have to take this A and multiply by P, and then B by R, and then we're going to add it. So it'll be A P plus B R will be our first term. Then we have to take A and multiply by Q, so this will be A Q, and then B by S, so plus BS, and then the other term will be C by P, which is CP, plus D by R, which is DR, and then C by Q plus D by S. Right, now I'm just recapping how you do matrix multiplication. So that's how I got the 1, 3, 2, 7. Right, just remember it's row by column. Now they said show that the matrix product A and B is not commutative. Right, so if you want to show that it's not commutative, we just worked out AB. So what we need to do is work out BA. Right, so we're going to do the product in reverse order. So that'll be 1, 2, 0, 1 multiplied by A, which is 1, 1, 2, 3. Right, so we're going to apply row by column again. So 1 by 1 will give me 1, and 2 by 2 will give me 4, so this will be 5. Then I'm taking this row and multiplying by this column now. So 1 by 1 will give me 1, and 2 by 3 will give me 6. So 6 and 1 is 7. 0 by 1 is 0, and 1 by 2 is 2. So this will be 2 here. And then we say 0 by 1, which is 0, plus 1 by 3, which is 3. Right? So therefore, we've proven that the product of AB is not commutative, right? Because we got two different answers. So this is what we've just proven. AB is not equal to BA. All right. Now they ask us to find the inverse of A. So this is the vector A, the matrix A, sorry. Right. So the first thing we need to do is to find the determinant of A, which is 1 multiplied by 3. So it's 1 by 3 minus 1 by 2, which is 3 minus 2, which is 1. Right? So the inverse is equal to 1 over the determinant. So the determinant is 1, so it's 1 over 1. And we have to do something with the matrix A. Right? We have to write down the adjoint matrix, which will be 3, 1, and minus 2 minus 1. Right? Which is the same as saying 3 minus 1 minus 2, 1. Right? Because 1 over 1 is 1. So we don't necessarily have to include the 1 in front of it. So just remember that if you have a matrix A and it's given by A, B, C, D, then the first thing we need to do is to find the determinant, which is AD minus BC, and the inverse now of the matrix will be equal to 1 over the determinant, which you would have worked out, and then we have to put the adjoint matrix, which is DA. We swap in these two positions. That's what we did. I put a minus sign here and a minus sign here. Right? So given any matrix, this is the inverse. Right? A 2 by 2 matrix. Right? So that's it for the third part. Alright, so in part 4, they said we have a matrix M given by this. Calculate the values of x for which the determinant is equal to 0. Right? So we know that when the determinant is 0, this is a singular matrix. Right? So whenever you see the word singular matrix, just know that the determinant is equal to 0. So when you have a matrix, if you have a matrix M and the matrix looks like this, A, B, C, D, then the determinant is given by A, D minus B, C, and they are telling us that the determinant is equal to 0. So therefore 2x multiplied by 3 minus BC, which would be 2 times 9, is equal to 0. So this will be 6x minus 18 is equal to 0. 6x equal to 18. Therefore x is equal to 18 over 6. And therefore x is equal to 3. Right? So they said the value or values of x. In this case, we have one value, so x is equal to 3. Right? Now we have a vectors question here. Now I'm not sure if students they don't pay much attention to vectors, or it's too difficult. Sometimes teachers teach it at the end of Form 5, so students tend not to pay much attention to it, and it can be very difficult sometimes, and it depends on how it's taught in school. Alright, but I can assure you, when I started vectors, it was difficult, but eventually, after much practice, it began to make sense. Right? So, okay, so we have position vectors R, S, and T relative to an origin, and they gave us these vectors here, the column vectors. So therefore, what we can say is that OR is equal to minus 3, 4. right? This is information they give us here, right? You just need to write it in a way that will help you in the question. So OS is equal to 1 1 1 1, and OT is equal to 5 minus 2, right? Now the first part, part 1, they ask us to find this here. What does that mean? Once you see a vector with vertical lines on either side, this is the modulus of the vector or the length of the vector. So this is modulus or length, right? Because remember, a vector has both a magnitude and a direction. So it's the modulus or the length or the magnitude of the vector. Make sure you understand that too. So if you see, if an arrow represents a vector, then the length of the vector represents the magnitude. And typically we have the x value and the y value, and therefore we can find the length. So we want to find the magnitude of OR. So OR, all you need to do, you know what the vector OR is. It's minus 3, 4. And really what you're doing is applying Pythagoras' theorem here. So you're going to say minus 3 squared plus 4 squared, and we're going to find the square root of that. This will give me 3 3s are 9 plus 16, and you're going to find the square root. So this is 25. So therefore the magnitude of the vector OR is 5, but don't just leave it as 5, put 5 units, right? Now we want you're gonna find RS. Now some people teach addition of vectors and subtraction of vectors. To me, just look at everything as addition, right? So like we want to find RS. Let's draw a quick diagram. So we have O. Now this may not necessarily be true how I'm drawing this. R, S, and T, right? I'm just drawing a diagram that will help me answer the question. So we want to get the vector RS, right? In order to go, think of it as moving from one position to the next. So I want to move from R to S. One way of doing that is going from go RO and then go O to S. So if I'm going to write that, it's going to be RO plus OS, right? Which is equal to, what is RO? We know what OR is. So therefore RO will be in the reverse direction. So if you want to reverse the direction of the vector, you just have to change the signs. So this will become 3 and this will become minus 4. And we're going to add OS, which is 1 1 1 1. This will give me 3 and 1 is 4, and minus 4 plus 1 will give me minus 3. Alright, so this is the vector RS. Now what is ST now? Go back to my same diagram here. ST, I'm starting at S and I want to end up at T. So it'll be SO plus OT. So this will be SO plus OT, right? Which will be, what is SO? SO, we are going in the opposite direction, so it'll be minus 1 plus OT, which is 5 minus 2. So minus 1 plus 5 will give me 4, and minus 1 plus minus 2 will give me minus 3. Right? Now look at this here. We want to find, let's say, vector RS. We are starting at R and we are ending at S, and we have a common point which is O. The same thing for ST. We are starting at S, right, ending at T, and we have a common point which is O. Right? The diagram is what's going to help you work out this question, so please pay attention. Please always draw a diagram, and vectors can be very easy. Okay, so the third part now that says using results of combining the vectors in B2, justify that RS is parallel to ST. Now this is a typical question that they will ask on vectors. Show that two vectors are parallel, or show that they are parallel and they are on the same straight line. To show that two vectors are parallel, one vector must be a multiple of the other, right? And if they are on the same straight line, then they must have a common point. So what you have to say for the third part, you notice that RS, which is 4 minus 3, and ST is 4 minus 3, right? Which means that RS and ST, so you say RS and ST are in the same direction, right? Because they're the same vectors. And also they have a common point S. I'm sorry. So they have a common point S, right? So therefore R, S, and T all lie on the same straight line. Okay? Now back to this parallel thing here. It just so happened that both RS and ST are the exact same vectors, but they may not, in a question it is not absolutely necessary that they are the same. So for example, ST could have been 8 minus 6. So what you would have to do is show that one vector is a multiple of the other. Okay? But I will do more examples on this in upcoming videos. Okay? So I hope you just try to pay attention to the vectors question. Can be very easy. Okay?